Our universe has been existing for billions of years. Since a significant explosion called the Big Bang. At that time, a tremendous number of explosions have happened among all the particles to form new atoms, new substance, or even the water we drink and the land we live on. So, as intelligent creatures as our human beings, we have tried our best to accelerate particles, to imitate these procedures, and to create new elements like what the Big Bang did. Cyclotron, a kind of particle accelerator that can accelerate particles into nearly light speed. According to the kinetic energy equation, kinetic energy equals to half of the mass of the particle times its velocity square. So, when the square is nearly light speed, it will causes a very large amount of kinetic energy. And when they collide into an element, into a nucleus, the kinetic energy will transfer into the nuclear energy so that a new element is made. To understand this topic, it's really easy for our grade 12 physics student. So this procedure is really related to the electric field and magnetic field. So both of the field will change the movement of particles in the field. The procedure of acceleration is accomplished. So now let me introduce how the cyclotron works and how it creates new elements.
As we all know, substances are made of lots of atoms, and atoms are made of positively charged protons, negatively charged electrons. Electrons are moving around the nucleus in their own orbits randomly. Hydrogen, helium, they are different atoms because they have different number of protons and electrons. So do lithium, beryllium, and boron. Respectively, their proton number is continuously increased with their atom number from 1 to 5, also their electron numbers. So we can say that the number of protons decides different atoms or different elements. With this, scientists place two metal boards into a vacuum. One of them is positively charged, the other one is negatively charged. Then, if you put a proton between the two boards, it will be given an electric force pointing downward. In order to balance this force, a magnetic field is placed pointing inside the paper, which is represented by red pen. According to our red hand rule, we can figure out a magnetic force is given to the proton, pointing upward. With knowing the equation, the magnetic force equals Coulomb times velocity times magnetic intensity, while the electric force equals to Coulomb times electric field density. To simplify the equation, we can get a velocity depending on the intensity of both electric field and magnetic field, pointing forward. Then, the accelerated proton will be transported into a new device to make a further acceleration, where two semi-sphere boxes filled with magnetic field. In order to make the magnetic field always points to mid-circle, the direction of magnetic field is changed periodically by using alternating current. Sending a bunch of protons or electrons from the center, particles will make circular motion with this speed up dramatically. After several periods, the speed can increase to be really fast. That's nearly the light speed. If we crash a nucleus with a bunch of high-speed protons, the positive proton will become part of the nucleus, which adds the number of protons within the atom. Once it's added, it is no longer the previous atom, but a brand new atom. Scientists have used this way to discover and create lots of new elements that not exist in nature.